The Johnstone Supply Company Cafferty Group, with offices in Nebraska, Iowa, Kansas, and Colorado, presents Fujitsu Airstage VRII Heat Recovery System Electrical Installation. In this section, we will discuss electrical wiring and transmission wire installation. Electrical wiring precautions. Wiring connections must be performed by a qualified electrician in accordance with the specifications and local codes. The rated power supply for this product is 208-230, 60 Hz, 3-phase. Before connecting cables, make sure that the power supply is turned off. When installing the system in a high humidity location, use a ground fault equipment breaker, or GFEB, to reduce the risk of leaking current, which may result in electrical shock or potential fire. Be sure to install the correct size breaker and wiring. When selecting breaker and wire size, please comply with your local codes and the National Electric Code. Do not use splices to extend the power cable. Improper installation can cause electrical shock or fire due to poor connections. Make sure to secure the insulation portion of the connector with a cord clamp. Damaged insulation can cause a short circuit. Before servicing the unit, turn the power switch to off. Then, do not touch the electrical parts for at least 10 minutes due to the risk of electric shock, since they will hold power in the capacitors. Use crimp-type terminals and tighten the terminal screws to the torque spec specified in the installation manual. Otherwise, abnormal overheating can cause serious damage to the inside of the unit. Faulty installation can cause a fire. Never bundle the power wire, transmission, and/or remote control cables together. Separate by a minimum of 2 inches or more. Here's an electrical checklist. Make sure the wires are rated for the breaker rating. The breaker should be rated for the condenser maximum overcurrent protection. LawnWorks compatible cable is a must. Normal electrical tools for the installation are required. Outdoor condensing units, RB boxes when they are applicable, and the indoor units and accessories. Here are a few things to note. When you're running 3-phase power, be sure to get the wiring in the correct phase. When running the transmission wire, you must use LawnWorks compatible cable. Wire lengths must be within specifications. Wiring must be on the correct terminals and tightened to the required torque specs. Unit must have correct voltage for proper operation. When running wires longer than 100 feet, calculate the voltage drop. Connecting to the outdoor unit. Knockout holes are provided in the front and the side of the condenser for conduit connection. Use the correct connections when running wires through the conduit. See the sizes listed below. Connecting and securing wires. Use crimp-type terminals with insulation sleeves. Securely clamp the crimp-type terminal to the wire using the appropriate tool. Use the appropriate screwdriver to tighten the screws, and tighten to the correct torque specs, which can be found in the installation manual. Circuit breaker ratings. For the outdoor unit, listed are the ratings for the 72, 96, and 120,000 BTU outdoor units. Each outdoor unit requires its own breaker. Do not connect multiple condensers to one breaker. The RB boxes and the indoor units are much lower amp draw, so you can wire a single indoor unit on a breaker, or you can wire multiple indoor units on one breaker. You can also wire a single RB box on a breaker, or multiple RB boxes on a breaker. See the chart to the left and in the installation manual for more information. Local codes may require a non-fused disconnect or safety switch at each indoor unit or RB box. Again, use crimp-type terminals and tighten the terminal screws to the torque specs that you can find in the installation manual. Secure the wires with binders or zip ties and cable clips. For indoor unit power connections, the M4 screws tightening specifications are 11 to 16 inch-pounds of torque. When you're using stranded type wire, use a crimp type connector to connect the wire to the terminal block. If you're using a solid core wire, make a cable loop on the end of the wire and connect that to the terminal block. Torque specifications are the same. Transmission wire. The following cable must be used when you're doing transmission or communication wires. The use is for transmission cable. Size 22 gauge. The type is level 4 NEMA, which is non-polarized 2-core twisted pair solid core diameter of 1/32 of an inch. And that is LawnWorks compatible cable. LawnWorks compatible cable 22 gauge minimum, though bigger wire may be used, but it may be difficult to get the connections under the terminals, and too big a wire could cause communication problems. Transmission wire design. See the wiring schematic on this page. When lengths AB plus BC plus BD is greater than 1,640 feet, a signal amplifier is required. Keep the transmission wires as short as possible. You will need a signal amplifier if the total length of the transmission cable is more than 1,640 feet. The total number of components or units is more than 64. That's outdoor units, indoor units, central controller, touch panel and system controllers, web monitoring tool, LawnWorks, and BACnet. Combined maximum wire length for all the communication cannot exceed 11,811 feet. Basic communication wiring rules. Total transmission wire length. Maximum 11,811 feet. That is a total of all of the components together. Transmission line between each unit maximum is 1,312 feet. Transmission line between the outdoor units in a refrigeration system, maximum 59 feet. Be sure to set one terminal resistor in the network segment. In the following cases, signal amplifier is required when the total line length of the transmission line exceeds 1,640 feet, or when the total number of units is over 64. Transmission wire design for manual addressing. All outdoor units, indoor units, and some remote controllers require addressing to communicate with each other. Choose either one of the two types of wiring patterns for manual addressing. Remember, keep your communication wire as short as possible. On the left, you see a daisy chain or series wiring, meaning all of the outdoor units and indoor units are in series with a daisy chain, one in and one out each indoor unit. On the right, you see an example of a parallel wiring system where the bottom system runs a transmission line to the indoor units connected to it. Top system runs a transmission line to the indoor units connected to it, and then the two outdoors are communicating as well. Here are some examples of a good transmission wire design. Here are some examples of bad transmission wire design. Let's talk about what makes a good and a bad transmission wire layout. In this example, you'll see the good design on the left. RB group number 1 has 3 indoor units that are wired together, they pipe together, and they connect to the same refrigerant branch. RB Group 2, we have 2 indoor units connected together with refrigerant lines to the one RB box. For the bad side, you will see that all of the indoor units are daisy-chained together. We can only have the communication circuit connecting where the refrigeration circuit that runs to that unit is connected. By putting the jumper wire between Group 1 and Group 2, that's telling the system that there's really only one group there and it doesn't know which valves to open when a unit is calling. This is an example of a multi-type refrigerant branch unit. You'll see the good section on the left. Group 1 is wired and piped to one port of the branch box. Group 2 is wired and piped to one port of the branch box. Group 3 and 4 are wired each to individual ports of the branch box and piped to each port of the branch box. So when that unit calls for cooling or heating, it knows which valve to open. The system on the right, again, as in the last example, we have a daisy chain of all of the indoor units, so the system would become really confused not knowing which ports to open when there's a call for refrigerant from an indoor unit. Here's another example of a multi-port RB box. Each indoor unit is in its own group and connected individually to the port it's piped and wired to. The example on the right shows that the farthest two right units are connected with the communication between them. The unit on the far right needs to be wired to the main daisy chain so it can communicate individually and not through the same port as the fourth RB unit connection. Wire design for the refrigerant branch box wiring. You see in the diagram below that there is power connections and transmission or communication connections on these units. Tighten the terminal screws to the specified torque shown in the manual. Otherwise, it may overheat and possibly cause damage to the inside of the unit. Torque specs. Tightening torque for the M3 screws on the transmission line should be 4 to 5 inch-pounds of torque. To peel the film from the lead wire, use a dedicated stripping tool that will not damage the conductor. When installing a screw on the terminal block, do not cut the cable by over-tightening the screw. On the other hand, an under-tightened screw can cause faulty contact, which would cause a communication failure. For the refrigerant branch box wiring, remove the 3 screws in the control box cover. Tighten the screws on the wiring to the specified torque specs. Cover holes and penetrations in the box. Transmission wire connections to the outdoor unit or refrigerant branch unit. X1 and X2 are the connections on the outdoor unit, the other RB unit, or the indoor unit in cooling-only situations. The indoor unit in cooling and heating uses the X1, X2, and ground. You will see that written above the connections. Do not use the 3 connections to the right. Refrigerant branch box wiring. Connect the transmission cable to the transmission cable terminals. Firmly attach the transmission cable using the accessory wire ties. Attach the conduit connector to the wiring connecting port. Connect the power supply cable to the power supply terminal. Fill the cable holes with putty in order to prevent small animals from entering. And install the box cover using the 3 screws we removed. Transmission wire design. When you're stripping insulation from the lead wire, always use a wire stripper or such tool. If there is no wire strippers available, carefully strip the coating off of the wire using a cutter so that you don't damage the conductive wire in the center. If the wire is damaged, it may lead to an open circuit and a communication error. Pay attention to the following points when you're attaching the wire to the terminal board. Do not attach 2 wires to one side of the terminal. Do not twist the wires together. Do not cross the wires. Make sure the wires can't short together, either entering or leaving the terminal block. And wire the system as highlighted here. In this schematic diagram, you'll see the location of the outdoor units, the refrigerant branch boxes, the indoor units, and the remote controllers. This slide shows the refrigerant piping. Here we have added the transmission and power wiring. Power wiring is indicated by dark red lines. The transmission wires for the communication system are in orange with the shield around the outside of them. The purple wires here are your remote control wires. Please carefully follow the wiring diagram in your installation instructions. You'll notice that the power lines on each of the indoor units are showing two breakers. Breaker 1 is a ground fault equipment breaker, or GFEB. Breaker 2 is your maximum circuit breaker. If you have multiple refrigerant circuits on this job site, these are the connections for the wiring between this refrigerant circuit that we're looking at and the other refrigerant circuit that's on site. Here are the connections between all of the outdoor units on this refrigerant circuit. Here is the connections on the circuit between the outdoor unit, the RB boxes, and the indoor units. Here are the connections for the remote controllers. You'll notice here that two of the indoor units are connected together. That means that they are both in the same space. This could be a larger room where we could have a controller at each end of the room, and in this case, those two controllers would mirror each other. When you change the settings on one, the display would change on the other. Here are the connections on the outdoor unit terminal block. The transmission line to the RB unit only on the master outdoor unit connects to X1, X2, and shield. The transmission line to the other refrigerant units use only on the master outdoor unit as well, Z1, Z2, and shield. Transmission line to the other condensers on the same refrigerant circuit, also known as the slave condensers, H1, H2, and shield. The indoor unit terminal blocks. The transmission line between the indoor and the outdoor unit, or between indoor units, is the X1 and X2. The indoor unit standard remote controller connection is Y1, Y2, and Y3. Keep the wires as short as possible. When wiring standard remote controllers, match the factory side wiring colors to the terminals at both the indoor unit and remote controller. The transmission line wire connections for automatic addressing. All outdoor units, indoor units, and remote controls require addressing to communicate with each other. Remember, keep the wires as short as possible. Automatic addressing can be used on systems with less than 45 indoor units connected. The below wiring design is the only option to wire all units to properly conduct automatic addressing. The system can be automatically addressed using a function, but manual addressing is strongly recommended. Follow the quick start guide that is attached to the condenser for addressing and function setting instructions. Wired remote control connections. Use remote control cable, 22 gauge AWG, shielded, polar, 3-core wire. There's 33 feet of wire provided with the remote controller. 3-wire type remote controllers are compatible with heat pump and heat recovery type indoor units. Confirm by ensuring that the indoor unit has a model number ending in RLAV or TLAV. Here's the terminal block on the remote controller. Match the wire colors, red to red, white to white, black to black, at the remote controller and the terminal block on the indoor unit. Here's the wire layout for the 2-wire type controllers. This is remote control cable, 22 gauge, shielded, polar, 2-core, LineWorks compatible wire. 2-wire type remote controller is compatible with the heat recovery type indoor units only. Heat recovery type indoor units are backward compatible with the heat pump condensers. Confirm by ensuring that the indoor unit has model number ending in TLAV. Here's a terminal block on the remote controller. The 2-wire type remote controller is not polarity sensitive. Here's a picture of the terminal block on the indoor unit. Here are the wiring connections on a touch panel controller. You'll see the power supply, which is 100 to 240 volt single-phase AC, and the power supply ground. Terminals X1, X2 run LineWorks wire to any indoor unit terminals X1, X2. Here is the location of the power supply connection terminals. Here are the connection terminals for the LineWorks connection X1, X2, and Shield, and the external input channel 1, K1, K2, and channel 2, K1, K2. Here are the wiring connections for the centralized controller. The power supply, single phase, 100 to 240 volt AC. DC power from the power supply to the controller, red, black, and green wires. Terminals X1 and X2 run LineWorks wire to any of the indoor terminals X1 and X2. Never apply high voltage to low voltage terminals. Did someone turn power on to the system before the piping was completed? All of the indoor units and the condensing units have expansion valves that will close when the power is turned on. If the piping has not been completed, that will interfere with the leak testing, evacuation, and charging of the system. If that's happened, what do? You can open the valves by following these instructions. Turn on the power supply to both the outdoor unit and the indoor units. Press the mode exit button on the outdoor unit. Look at the 7-segment display. Change that display until it displays F3 by using the select button. Press the enter button. Change the display to 21 by using the select button. Press and hold the enter button for 5 seconds. The display will now show POFF, or power off. You may turn off the power to all of the units and those valves will remain open. This process will also open all of the RB solenoid valves, which may be needed during leak test, evacuation, and charging of the system. If you power the system off, the solenoid valves will close. They are powered open and they fail to the closed position. Thank you for joining us for this presentation on the Fujitsu Airstage VRII heat recovery system electrical installation. If you have any questions or you need more information, please contact your local Johnstone Supply Cafferty Group office.